everybody and welcome to Primary 6A's YouTube channel. I hope everyone's doing really well and you're getting on okay. Obviously this is very different to what we're used to, so it will take just a little bit of getting used to, but I'm sure over time we will get there. So as always, if there are any questions that are for me, then you can contact me via Teams, and that is the best way to contact me. Also remember to share any finished work with me also on Teams. You can do that via the class notes section, and if you do upload work there, make sure you let me know by posting on the feed that you have uploaded something there for me to go and look at. If there are any problems with that, again, just pop a message and I am always here to help the best I can. So for this week's learning, we are going to be covering videos on 2D shape, including triangles and circles, and also for grammar, we are going to be looking at homophones. The next clip will give you more details about the learning taking place this week. So our first video is going to be all about 2D shape. 2D shape refers to shapes which are two-dimensional, which means they usually have a length and a width or a breadth. They are flat shapes is what children might also be more familiar with them being called. And the first step for people to be working on is to be able to name and identify different 2D shapes. Here I have a selection of very basic 2D shapes that we would really expect primary sixes to be familiar with at this level. So obviously circle, square, rectangle and triangles. And the differences between them, for example, looking at their properties, we have shapes with curved edges, we have shapes with straight edges, we have shapes with one curved edge, four edges, and three edges. And then looking at these two, because they both have straight edges and four edges, the difference being that this one has two longer lengths, as a square should be the same length all the way around. Pupils will increasingly become familiar with a greater variety of 2D shapes and their groups. So for example, here we have triangles, which we will go on to speak about in another video in greater detail. Our next group of 2D shapes include quadrilaterals, which are four-sided shapes, which is where they get the word quad from in their name. So a selection of these shapes pupils will be more familiar with. For example, in our common shapes, we already mentioned squares and rectangles. Pupils should also probably be familiar with, for example, a kite. They may have heard of rhombus there and parallelograms, and they might not be so familiar with trapeziums. Similar to when in the first instance when we looked at our shapes, people should recognise the differences between all these shapes, particularly as they all have four straight edges. So we've already detailed that the differences between a square and a rectangle is that a square has four equal length of sides, and a rectangle has two longer sides and two shorter sides. However, focusing on our four shapes here, including rhombus and parallelogram, a rhombus also should have four equal sides, forgive my sketch there, and a parallelogram, similar to a rectangle, has two longer sides and two shorter sides. So I have deliberately organised them in this way so you can see that comparison. However, the differences being, as I've shown on the angles in the corners, that a square and a rectangle has four right-angled corners, which is our L-shaped corners people should be familiar with. For example, at the same corner of a board or a corner of a table, it is usually a 90-degree right-angled L-shaped corner. The rhombus and parallelogram are slanted looking shapes, which is what the children might define them as, or diagonal versions of a square and a rectangle. they might describe them in that way. But what's actually going on is that their angles are no longer right angles. And in fact, opposite angles, we have a pair of obtuse angles and a pair of acute angles on each of the shape, depending what way it would be facing. So that's an important difference for pupils to see between a rhombus and a square and a rectangle and a parallelogram. Pupils do often get confused, in my experience, between rhombus and parallelograms, and it's just important to remember that a little bit like a rectangle, the parallelograms are the longer shapes and the rhombus are the more square-like shorter shapes. Also, with a rhombus, I'm not going to quite show you on the camera, but if you tilt your head to the side, a rhombus looks similar to a shape pupils would describe as a diamond. So that might work out there if you look at it from a side angle. And slightly less talked about and a little bit easier to differentiate, we have two other four-sided shapes, which is a kite, which has two shorter sides at the top and two longer sides. So the two adjacent next to each other sides are the same length, which is different from the rectangle, where it is the opposite sides which are the same length. And the trapezium has two parallel sides and then two sides that are not parallel. And we'll speak about parallel and not parallel in more detail in a moment, but those are the kind of things people should recognise about the shapes they're looking at. Pupils will also be familiar with shapes that have more than four sides. For example, five-sided shapes, which are pentagons, six-sided, which are hexagons, seven-sided heptagons, eight-sided octagons, nine-sided nonagons, and 10-sided decagons. Forgive some of my sketches there, please. Not only are they five-sided, but they also have the same amount of corners. So 5 corners for a pentagon, 6 corners for a hexagon, and so on. I've tried to draw here what would be known as regular hexagons, hexagons, heptagons, octagons, etc. However, they are only regular shapes if the sides have the same measurements if you were to draw these with a ruler, whereas these are just sketches on a whiteboard. But these shapes, if they were not regular pentagons and hexagons, etc., they would be known as irregular. For example, pupils have shown me before a pentagon, which is more of a house shape. So it has more of a boxed bottom, and although that would not be a regular pentagon, it would still be an irregular pentagon, or you could just call it a pentagon. So yes, people should be familiar with those properties as well. So after being familiar with all the names and different types of shapes, people should be able to give more information about each shape's property. So very basic information pupils would start to give early in the school would be how many edges does a shape have and how many corners does a shape have. As they go up the school, they might refer to a corner as a vertex or vertices, so 1 vertex, 2 vertices. So how many vertices does a shape have? For example, in a triangle, that would be 3. They should also be able to tell if an edge is straight or curved. They should begin to be familiar with the types of angles, which I'll go on to explain a little bit further, as well as whether the lines are parallel or perpendicular. So when looking at the vertices on a shape, pupils should begin to recognise that they equate to different types of angles, and pupils should already be very familiar with some of these angles, if not all of them. We mentioned already a right angle, which is your L-shape angled, a typical corner of a square or rectangular surface would be a right angle, and pupils should recognise these in straight edged shapes. However, straight edge shapes can also have acute angles, which are smaller than the 90 degrees, anything smaller than 90 degrees, or obtuse angles, which is more than 90, I can't quite tell there, but it's a little bit more than that one there. So more than 90 degrees, but not quite as much as a straight angle, pretty much a straight line, which is 180 degrees. You might notice it's essentially two right angles laid next to each other to make a straight angle. And lastly, a reflex angle, which is anything bigger than 180 degrees. It's called a reflex angle because it's usually the back of another angle. So for example, in here would be an acute angle in this little gap here. But around the outside would be its reflex angle. Pupils should also begin to recognise whether lines are parallel or not parallel, non-parallel, or even perpendicular in different 2D shapes. Parallel lines are pairs of lines which are going in the same direction. So the easiest comparison to explain this with is like train tracks. So they are going in the same direction, showing the pairs here. The lines, if they were to be extended, would never meet. So for example, if I just grab a pen here, something like that pair of lines would not be parallel, because if they were to be extended, if you use your imagination, I'll just use a pen, they would eventually meet. However, the opposite of parallel is actually perpendicular lines, which is where instead of going in the same direction, they go in the direct opposite direction, and they actually meet at a right angle, shown here, to go back to what we were speaking about earlier. And it creates this T shape, or an L shape, I guess, if you were to get rid of this. And again, I've shown you here, the lines don't necessarily have to meet. You just have to use your imagination, and you could tell that these lines would be perpendicular because they are going in the exact opposite direction. They are the opposite of parallel lines. Finally, another observation pupils should make about shapes are their ability to have lines of symmetry. Symmetry refers to an exact reflection of the shape across a line, usually down the middle. So it could be, obviously in this example we're talking about shapes, but it could also be in pictures. For example, you commonly use a butterfly to refer to lines of symmetry as one side is similar to another side. So in this example, we have a square, a isosceles triangle, and a parallelogram, as we have already seen today. And we are looking at how many lines of symmetry they have. To starters, pupils might be introduced to just say if this shape is symmetrical or not. So yes or no, the shape, yes it is. It can be folded in half, and it is the exact same on the other side. This shape can also be folded in half, and it is the exact same on the other side. However, this shape cannot be folded in half. It will not be an exact mirror image. So this shape has 0 lines of symmetry. It has no symmetry. This shape, the isosceles triangle here, only has 1 line of symmetry. It can only be folded once to show an exact mirror image on the other side of the fold. However, our square has 4 lines of symmetry, as it can be folded up and down the way, it can be folded across the way, it can also be folded diagonally at each of the corners. So in total, our square has 4 lines of symmetry. And pupils should also look at our other shapes that we've spoken about today and identify if they are symmetrical or not, and how many lines of symmetry they have. I hope that was informative. As always, if not, just give me a message, preferably on Teams. Thank you for watching, and happy learning. Bye!